In this video, we're going to talk about simplifying complex rational expressions. Now, don't be fooled. So far, you might think that we've been dealing with complex rational expressions, but they haven't actually been complex. What I mean by that, in this case, are fractions inside fractions, basically. So what you're going to do is you're going to always simplify the numerator and denominator, make them a single fraction. Then you're going to rewrite it as a division problem and divide. So remember, that'll be the keep the first fraction, change to multiplication, and flip the fraction, second fraction. So we're going to jump straight in. Notice here that we have a fraction inside a fraction. Really, this division bar here, this fraction bar means division. So look at the numerator, what's above that red line. It is a single fraction. Yay! The second fraction, the bottom, is going to be also a single fraction already. Yay! That means I can go straight into rewriting this with the division sign. And once I've written it with the division sign, I can then keep the first fraction, change to multiplication, and flip the second fraction. Now it's just a multiplication problem, all right? So you can see here that we'll factor the numerators, and denominators will multiply across, and then we'll cancel out anything that is the same for both, and we write our final answer, 3x minus 2 over 4. This should all look very familiar. Now, let's talk about this one, though. This is one where it requires a little bit of extra effort, because when we go ahead and we identify, again, this is the big fraction bar. I like coloring it because it makes it easier for me to see. I need to make sure that the numerator of the big fraction is a single fraction. 1 over x plus 1 over y is not a single fraction. And you know what? The denominator, x over y minus y over x, also not a single fraction. When I combine those into single fractions each, I'll be able to go through the rest of my steps. So taking a look at this, 1 over x plus 1 over y, my common denominator there will be xy. So the first one I multiply by y on top and bottom, and the second fraction I multiply by x on top and bottom. Okay, that's going to give me, well, I also need to do the same thing for the denominator. Again, the denominator is going to be xy. So I need to multiply by x on the first fraction, top and bottom, and y in the second fraction, top and bottom. So now I'm actually going to do that simplification. So I have y over xy plus x over xy over x squared over xy minus y squared over xy. So I can combine the first two fractions, the ones on the top, that's y plus x over xy. I can combine the fractions on the bottom, x squared minus y squared over xy. Then I'm going to write it as a division problem. At this point, we have moved straight into what we've been doing in these previous steps. All right, because division means I'm really multiplying by the reciprocal. Okay, now I can factor any expressions. Now in this case, what I can factor is the x squared minus y squared. And I can write that as x minus y, x plus y. I'm also going to go ahead and write this as a single fraction. Notice now a ton of stuff cancels. One thing I want to point out here is that y plus x is the same thing as x plus y because addition is commutative. So that means that I can cross y plus x out with the x plus y. And I can cross the xy out with the xy. Now, it might look like this is 0 now, but don't be tempted to write 0 over x minus y or 0 as your answer. Because when I cancel, if there's nothing left in one part of my fraction, it's really like leaving a 1. So this really becomes 1 over x minus y. All right, see? Not so bad. Let's try another one. When you look at this one, first of all, we want to recognize that n is n over 1. And that, again, this is our fraction bar. So in the numerator, what is our lowest common denominator? Well, the lowest common denominator for the two things in the top is going to be n plus 5. And the only one that is missing that is actually the first one, n over 1. That's one we'll have to multiply by n plus 5 on top and bottom because the second fraction already has the correct denominator. Now let's take a look at the denominator. All right, we have two fractions there. Their denominators are n plus 5 and n minus 5, respectively. So those both need to be included in the lowest common denominator. So we multiply the first fraction by n minus 5 on top and bottom, and we multiply the second fraction by n plus 5 on top and bottom. Now that we've done that, we're going to go ahead and simplify the numerators and simplify the denominators. Notice we've distributed anywhere that that's possible. And now on the top, we're going to subtract 4n, which 5n minus 4n becomes just n. In the bottom, we have n minus 5 plus n plus 5. N plus n is 2n. and -5 plus +5 is 0. So now we have a fraction on the top, a fraction on the bottom. So now that it's single fraction over single fraction, we can rewrite it as a division problem. We can multiply by the reciprocal, keep, change, flip. We can factor anything that's factorable. So in this case, n squared plus n can be factored as n times n plus 1. And then we go ahead and rewrite it as a single fraction. And then we just have to cancel out things that are repeated. So in this case, I can cancel out my n plus 5 and my n. When I write my final answer, I do bring that 2 underneath in the center, and I write my n plus 1 and my n minus 5 on top. Now, there's another method we can use for complex fractions and for rational expressions. It's up to you which way you prefer, but I want to show it to you real quick in case you like this. And that's by using the lowest common denominator, okay? If you find the LCD of all fractions in the entire expression, then you can multiply both the numerator and denominator by that value and simplify. What does that mean? Well, let's take a look at one that has just numbers. So in this case, 1/3 plus 1/6 over 1/2 minus 1/3. We want to look at all of the denominators. So that's 3, 6, 2, and then 3 is repeated. What is the LCD of 3, 6, and 2? Well, 6 is the smallest value that all of those go into. So the LCD is 6. So what I could do is I could multiply the top by 6, and I could multiply the bottom by 6. When I do that, it becomes 6 times 1/3 plus 6 times 1/6 over 6 times 1/2 minus 6 times 1/3. Now 6 times 1/3 is 2, 6 times 6 is 1, 6 times 1/2 is 3, and 6 times 1/3 again is 2. So this simplifies out to be 2 plus 1 over 3 minus 2. 2 plus 1 is 3, 3 minus 2 is 1. So 3 over 1 becomes 3. Now you can see that when it's just numbers, this is actually a super fast method. The question is it actually faster when you have things like this, all right, where it's not just numbers? Maybe, because keep in mind what you're doing is you're getting rid of the additional fractions, okay? You're just going to have one entire fraction once you're done with this. So here, what we want to do is we're going to figure out the LCD of every fraction. So when you look at this, x squared minus 36 is really x plus 6 times x minus 6. So when you do that thing where you line them up vertically, you're going to notice that x plus 6, x minus 6 is the LCD. So we're going to multiply everything by that. Notice that I leave my x plus 6, x minus 6 in its factored form underneath the 4 in the denominator. Now, when I am multiplying through, notice that my x plus 6s are going to cancel on the top, okay? And that's going to come out really nice. And when I've distributed to the other two fractions in the denominator, you'll notice x minus 6 cancels here, and x plus 6 and x minus 6 both cancel here. So simplify anything that you can, all right? That's going to make it 2 times x minus 6 over 4 times x plus 6 minus 4. So we do distribute the denominator, okay, by multiplying the 4 through, and then we're going to also combine the like terms in the denominator. So it's 4x plus 24 minus 4, which is 4x plus 20. And then we want to simplify. So notice I can pull a 2 out of the bottom and leave me 2x plus 10, and then that 2 cancels with the 2 from the top. Now that's going to leave me with x minus 6 over 2x plus 10. And even though you could pull a 2 out of the denominator, it would leave us with x plus 5. So neither 2 nor x plus 5 cancels with what's in the numerator. That means this problem is as simplified as it can be. So that's our final answer there. I hope that helped you a lot with simplifying complex expressions.